This is the third lesson about options. Today we're going to talk first about a synthetic future. A synthetic future is a future that is created by options. If we want to buy a contract, we need a synthetic contract, we need to buy a call option and sell a put option at the same price and time. If we want to sell a contract, we will need to buy the put option and sell the call option on the same execution date and price. Actually, it doesn't matter on which execution price we do that. The difference will be with the money flow, with the money we pay and we get back afterwards. But in gain and loss chart, it will be identical. Now, if we understand that we can create a synthetic future with options, we can learn a few more things about options. Now, the delta of a future is exactly like buying the asset, which means 100%. So the sum of the absolute value of deltas of call and put on the same execution price is also 100. That means that if a call option on a certain execution price is, for example, 60, the put option on the same price, the delta should be minus 40. Of course, that when we write the put option, the delta changes into a positive, and then the writing option, the put option, will have a 40 plus delta, and together with the 60 of the call, it's 100. Exactly the same when we sell a contract, it's minus 100. The call option, for example, is minus 60, and the put is 40. We buy it, so it's minus 40, and together it's minus 100 for selling short the synthetic future. Now, the implied volatility of a contract, of a future contract, is 0, because the contract determines, price is only determined by interest rate and the price today. So therefore, the implied volatility of the call option and the put option on the same execution price and time is identical, because one of them we buy and one of them we sell, and the sum of them is 0, so they have to be identical. Also, the gamma of a call option is identical to a put option when we buy it, of course. Gamma is always positive when we buy it. Why is that? Because the gamma of a contract is 0. The contract delta stays 100 at all with every change. So if we buy a call option and we write a put option, the sum of them is 0, the gamma is 0. That means that one of them we buy and one of them we sell is minus, and the sum is 0. That means that they have to be identical. Now I'm going to talk about the distribution of the implied volatility. That means the skew. Actually, with Black-Scholes model, we have a standard deviation of the market, which doesn't matter what strike it is, it should be the same standard deviation. That means that if this the execution price, it should be a straight line, and this is the implied volatility. It should be a straight line, and all asset price, all execution price will have the same implied volatility. But actually, it's not like that. How the implied volatility is distributed is called the skew. Many times we have a smiling skew. That means that the market think that to get up or downtrend has a higher possibility than the ordinary distribution that Black-Scholes assume. So in many markets, we find this smiling skew, but in stocks, we get a skew of investors. Skew of investors is a skew that the implied volatility in the lower prices, execution prices, is high. And when the execution price is going up, the implied volatility goes down as well. How a skew of investors is created? It's created because investors want to defend themselves. And they defend themselves, A, by buying a call option, a put option, to be sure that they will not lose if it goes down, not lose much. And to pay for this put option, they write a call option. When investors buy put options out of the money, the price of its price is going up, and the implied volatility is going up as well. And also, when they sell call options out of the money, the price is going down, and therefore the implied volatility is going down. So even if the market is positive, we can see that there is the skew of investors is going down from right to left. And if the market is negative, it can be even sharper than usual. Another kind of skew is a skew of shortage. If we are afraid to be without an asset, for example, if we're afraid that prices of gas will go up, of oil, and we are afraid that it will do, so people want to buy calls out of the options to make sure that they will not lose if there is a sudden increase in oil prices. So that's the skew. It's a bit smiling, but it's really sharp towards the price increase, because people are afraid to be without the asset. That's here for today. I hope you enjoyed.